Hi everybody. Today we're going to be going over some of the topics on your final exam. Today's review topic is trigonometry. If we were in the classroom, I would ask you to get your review notes out, and we're just going to go through this quickly just to refresh our memory on some of the topics we talked about during the course of the year. Obviously, most importantly, converting between degree and radian measure. You guys, you have to know how to do this. Remember, our brains think in degree, but a lot of times we're given radian measure. So to go from degree to radian, you're going to multiply whatever angle you're given by pi over 180 and simplify and leave in terms of pi. And if you have to go from radian to degree, this is usually what we're doing. We're going to multiply our given angle by 180 over pi, or just replace pi with 180 and simplify your answer. I know you guys have been doing this for a while, so I'm not going to really worry about those type of problems until we get to them in the course of the review sheet. Setting up trig function values, very important. Remember, a trig function value is the ratio of the side lengths of a right triangle. Listed below here are the 6 trig function values you should know. You should know how to get a trig function value off a unit circle, right? Remember, a point on the unit circle, the x-coordinate corresponds to the cosine of that value, and the y-coordinate corresponds to the sine of that value. And a lot of times we're going to use our unit circle to get function values of quadrant angles. We're going to move through this fairly quickly. Finding exact trig function values of special angles, we're going to use our triangles. So we have our 45, 45, 90 and our 30, 60, 90. Some of you use these side lengths. Totally acceptable. This is just a different way of saying the same thing. If you use this triangle, that's fine. Remember, when finding exact values, there's no decimals and no radicals in the denominator. So you have to always simplify your answers. We're responsible for finding function values of angles greater than 90 degrees in this course, in which case we're going to use a reference angle, and the steps are here, and a reminder of how to get the reference angle and what to do is over there. If the angle is negative, you can use even and odd properties, or you can add 360 to adjust your angle. And again, this is totally up to you. Inverse trig, that means we're going to find an angle that gives a certain function value. That's going to depend on the ratio and sine. Now, some of you had a hard time with this back in the trig unit, so we're going to do a couple of problems in a few minutes just to help us remember. Remember, our ratio gives us our special, ratio, we're going to use our special triangle or unit circle, and the sine, we're going to adjust our angle in a given quadrant. So our inverse function for the sine and tangent uses quadrants 1 and 4. The inverse function for the cosine uses quadrants 1 and 2. And if you don't have exact values, you have to build your own triangle. Analytic trig, not going to make a big deal of this right now. Just remember these formulas, know that they exist, and sometimes you may be asked to use it. If I ask you to use a sum or difference formula or a function of the double angle, I will make the formula accessible to you, or since it's an open book final, you'll be able to look it up on your own. Solving trig equations, this is big. We want to make sure we understand this topic. Basically, we want to isolate our angle, find a reference angle, solve for our positive function value. Then we're going to use our calculator, and then we use a reference angle to find the solutions in the appropriate quadrant, and we kind of use this as our guide. We also might be used to solve equations in our calculator. Basically, you want to plug the the equation into y equals and use second trace. So these are going to be the things that you're responsible for the most part. Lastly, things we need to know, just in general, know your basic sine and cosine curve. While you're not going to be asked to graph on the final, you should know basics about your curves. Average rate of change, that's our slope of the secant line formula. And, always, 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 any of our trig identities, you should know your basic trig identities and, of course, your Pythagorean identity. Okay, so those are the big topics that we went through when we were studying trigonometry in class. Let's answer a few questions. Let's look at the review sheet. So if you take your review sheet, I'm going to look at a couple in each section. Okay, the first question I'm going to look at is just plain old sine of 30 degrees. Now, whenever we're dealing with setting up a function value, we want to use our triangles. So if I'm going to set up the function value for the sine of 30 degrees, and I made a little handy dandy cheat sheet here. Okay, I'm going to work off my triangle. The sine of 30 is opposite over hypotenuse, so it is 1/2. We look at question number 3 on our review sheet. Here now, when I'm asked to find the sine of 210, that angle is bigger than 90 degrees. So if I think about where 210 is, falls in the third quadrant. So in order to get the measure of that angle, I'm going to do theta minus 180, or 210 minus 180, which is 30. So the sine of 210 is like finding the sine of 30 in quadrant 3. Well, the sine of 30 is 1/2. And in quadrant 3, remember, all students take calculus. In quadrant 3, the value of the sine is negative. So we found our reference angle, set up our ratio, adjust your sine. Question 6, the secant of 120. 120 is bigger than 90 degrees, so we have to figure out what quadrant it lies in. It's going to be in the second quadrant because it's between 90 and 180. So to find the value of that angle, the reference angle, 180 minus 120, we're setting up the secant of 60 degrees in quadrant 2. The reciprocal function of the secant is the cosine. So we're really doing the cosine of 60 degrees in quadrant 2, but we're going to remember we have to flip that at the end. The cosine of 60. Well, the cosine of 60, if we go to our triangle, the cosine of 60 is adjacent over hypotenuse. The cosine of 60 is 1/2. In quadrant 2, the cosine is negative. And then we're going to take this and we're going to flip this answer to set up the function value for the secant of 120. Okay. Sometimes, question like 11, sometimes our questions have more than one term and we have to do some operations or add, subtract, multiply, divide, whatever the case may be. Just follow the math. The cosine of 180, I'm going to use my unit circle. 180 degrees, the cosine is going to be the x value. So the cosine of 180 is -1. Now this second part, I can do one of two things. I can adjust my inside angle. The tangent of -45 is the same as the tangent of 315. Or I could do -1. Tan of -45, using my even and odd properties, tan of -45 becomes +1 times the tangent of 45. It doesn't matter which method you prefer. A lot of you are going to probably do it this way, though, so I'll continue this problem this way. Tan of 315. Well, 315 is a fourth quadrant angle, so we do 360 minus 315. Our reference angle is 45. So I want to set up the tangent of 45 degrees in quadrant 4. -1 minus the tangent, 45 degree angle, opposite over adjacent is 1. But in the fourth quadrant, tangent is negative. So I'm going to put -1 in there. And I have -1 plus 1. So this answer should be 0. Moving on, if we move on to the next section. The next section of problems is asking us to find the exact value of each of the remaining trig functions. Okay, so here what I'm going to do is take a look at number 13. If I'm given that the tan of theta equals -1/3 and the sine of theta is greater than 0, I want to set up the function values. Okay. Basically, what I need to do here, since I don't know the value of the angle, I need to build my own triangle. So first I have to figure out what quadrant to put it in. Opposite over adjacent. So I want to find out what quadrant the tan is negative and the sine is positive. And that happens in quadrant 2. So now this is my angle, and I'm going to use this angle to help me. Opposite, adjacent, and since this is the negative part of the x-axis, I'm going to put the negative sign there. I need to find the hypotenuse. I use the Pythagorean theorem. So I have 9 plus 1. So c squared equals 10. So c equals radical 10. So that side length is radical 10. And then I'm just going to use my triangle to set up my function values. I'm not going to go through all of them. You can go on your review sheet. But the sign would be 1 over radical 10. But remember, no radicals in the denominator, so you get radical 10 over 10. The cosine would be adjacent over hypotenuse. And so forth. But again, I just wanted to refresh your memory on how to set it up. You can finish this problem on your own. The next section has to do with finding the exact value of each expression. When you see this notation, that means you're dealing with inverse trigonometry. Okay, so we're basically solving for an angle. If we take a look at number 14, I want the angle whose sine is radical 2 over 2. So I have a ratio, and I have basically a sign. In this case, it's positive if there's nothing there. The ratio will give us the angle. The sign will give us the quadrant that angle is in. And that will be our answer. So what angle gives us a sine of radical 2 over 2? Well, that would be 45. And since I have a positive function value, I'm going to take the first quadrant value of that angle, which is indeed 45 degrees. If we take a look at something like number 16, reading this problem, I have the angle whose cosine is negative radical 3 over 2. And after I get that, then I'm going to set up the tangent. So I have the angle whose cosine is negative radical 3 over 2. Remember, that gives me the angle, and then I adjust the angle based on the quadrant. So what angle gives me a cosine of radical 3 over 2? Well, that would be my 30-degree angle. So 30-degree angle, but I want the second quadrant value of that angle. So what's the value of 30 degrees in quadrant 2? 180 minus 30 is going to be 150. What is the tangent of 150? Well, now the tangent of 150 is going to be the tangent of 30, because that's my reference angle, in quadrant 2. What's the tangent of 30? Tangent is opposite over adjacent, 1 over rad 3, which is rad 3 over 3. And because this angle's in quadrant 2, I have to negate that. And there's your final answer. Moving down to the next section, solving each of the following equations. So now we're solving in the interval 0 to 360. So I'm going to look at number 25 with you, because it's a good kind of mixture of a whole bunch of things. If we look at, I'll do this on a piece of paper. Cosine of 2 theta equals cosine theta. The first thing we have to do is realize that here I have a double angle, and this is just a regular angle. Okay, so I should be able to recognize that in this case, for this particular problem, I have to rewrite this using a double angle formula. So I would go to my double angle formulas, and I would see that it would make sense to rewrite it with that formula. So I have 2 cosine squared theta minus 1 equals cosine theta. And now hopefully you recognize that this is a quadratic. So with a quadratic equation, we like to get everything to one side. Now I can factor this. I'm going to use my little bridge or rainbow method. 2 cosine theta, 2 cosine theta. What two numbers multiply to -2 and combine to give me -1? Well, that would be -2 and +1. I put in a factor of 2, I have to take it out. So I have cosine theta minus 1, 2 cosine theta plus 1 equals 0. And now I'm going to continue on, set each of these factors equal to 0. So one batch of solutions is going to be where cosine of theta equals 1 and where cosine of theta equals -1/2. So continuing on, where does the cosine of theta equal 1? Hopefully you guys recognize this is a quadrant angle, right? We get our zeros and ones from quadrant angles. So the best way to get this solution is to go to your unit circle. Where is the cosine of theta equal to 1? Well, that's going to be at 0. Okay. And now I just want to double check because I forgot. I'm solving it. I'm not including 360, so I don't have to worry about going all the way around the unit circle. I just have theta equals 0. Now cosine of theta equals -1/2. Now here, you can use your calculator for this, right? If you want to. You just have to, since you're solving for an angle, we want to make sure our calculator is in degree mode. If I'm in degree mode, I can just second trace, right? Basically, you want this. We want the angle whose cosine is 1/2. Remember, we're going to solve for the positive function value. This is going to give us our reference angle. So I'm going to do second cos 1/2. Some of you may remember this is 60 degrees. Okay, right from your triangle. That's okay if you do it that way. So my reference angle is 60 degrees. Now what I need to do is that I need to figure out, I don't want that. I want the solutions are going to be where my cosine is negative. So I want to find the values in the second and the third quadrant. So in the second quadrant, I'm going to be looking for, or my angle is going to be 180 minus 60. Theta is 120. And in the third quadrant, my solution is going to be 180 plus the reference angle. So my solution is going to be 240. So the overall answers for this problem are 0, 120, and 240. And it's not necessary to rewrite this in terms of pi. I will accept that as your answer. The last question we're going to look at is number 26. Number 26 is a little different, and number 26, I believe, if you look on your sheet, we're only solving in the interval 0 to 180. Now here, if I use a double angle formula to rewrite this, it's not going to help me. If you remember talking about this in the course of the year, we can't do that. So we have to use a different method here. We have to take our 2 theta and we have to replace it. We're going to solve for some angle. So basically we want to find the angle, right? The angle that gives us a sine of 1/2. So we're going to second sine 1/2, and we get that A is equal to 30 degrees. And where else is the sine 1/2, right? Where's our other solution? A is also going to be, it's positive in the second quadrant. So 180 minus 30, A is 150. But we're not solving for A. What are we solving for? A is 2 theta. So we let 2 theta equal 30. And we let 2 theta, equal 150. And the solutions for this problem are 30 divided by 2 is 15. And 150 divided by 2 is 75 degrees. Now, you could also do this on your calculator if you wanted to. Okay. If you were going to answer something like this on your calculator, though, your answers would look very different from these. Let's just talk about this. If we were solving this on our calculator, we would have to take everything and set it equal to 0. And then we put this expression. The other important thing here is we'd have to use radian mode. This is sometimes what we do in calculus. Okay, we have to know both methods. So we would go and we would do sine 2x minus 1/2. And you'd zoom 7 that, we'd graph that. Now, if I want to find the solutions between 0 and 180, I would just use my second trace 0 function. And there's my x is going to equal 0.26, let's say 0.262. And then the second solution over to the next x-intercept. And my next solution will be x equals 1.309. Now, these two values look extremely different, okay, but they really are the same answers. I mean, you could tell by the graph, if this is 90 degrees, this looks like 15 degrees and 75 degrees, okay? They just look very different because of the fact that one is in degree and one, the answer is a radian. Okay? If you were to get a question like this on your test, it would become very obvious. I would say to use your calculator, and then you would give me the answers like this, or it would say do it algebraically, and then you would give me the answers like this. All right, so that's just a little bit of review on some of the trig topics. Good luck. I hope you found this helpful.